But since we are not allowed to use a graphing calculator, but I want to show you what I'm talking about here. If I graph that function, can you see it? Or should I move it? Maybe. Here we go. That's better to see. Yep. Graph it. So you can see when you look at it, it says infinite limits. What that means, as x approaches 2 from the left side, where's the function going to? If you look at my picture, which is what? Negative infinity. From the right side is what? Plus infinity. So we're talking about one-sided limit here. That's what we're going to be talking about all these questions. Because the limit at 2 does not exist. So if they're going to ask you anything, let's say, what is the limit as x approaches the 2 from the left side? And my answer is really negative infinity. From the right side, my answer is what? Plus infinity. So that's what infinite limits. As you approach it, it's either going to go to plus infinity or the minus infinity. Again, since we are not allowed to use graphing calculators on the test, how do we get the answer to these? Again, the only way is the table. Take values for x and see what the y value is. Notice you come into the 2 from the left side. You're not at 2 yet, like a 1.9, 1.99, 1.999. And you'll see where the y value is going to. Plug them on that cheap calculator there. We don't need anything fancy. So we'll go 1.9, negative 30, 1.99, negative 300. Doesn't take that many values to get the answer. 1.999, negative 3,000. You can see that number is getting bigger and bigger on the negative side. That's definitely going to negative infinity. For the right side, x and 3 over x minus 2. If I pick a 2.1, that should give me a 30. If I should pick a 2.01, should be 300. 2.001 should be 3,000 positive. And you can see that number going toward positive infinity. But there is no limit as x approaches the 2. So you're going to be asked to find the limit either from the left side or the right side. Now some of them you can plug them in and see if it's going to be a negative or positive infinity, and it works out nicely without making the table. But not this one. Let me take another example or two here. F of x equals 2 over x minus 3. Notice this is actually squared in the bottom. And what's the limit as x approaches the 3 from the left side? Or the 3 from the right side, or even just the 3 in this case. Now again, we can go to the table and pick values, but if you look at this, if you pick a value less than 3 from the left side, like 2.999999, right? You subtract 3 from it. So 2.99999. Oh, where's my calculator here? Quit. Let's try some value. 2 divided by, not times. If you make a table in your head quickly there. And let's pick a number close to 3 minus, like 2.999999 minus the 3. That's close to 3, right, from the left side? But this number, you know it's a negative, but the fact you're going to be squaring that, what do you think is going to happen to that number? Becomes positive. That would go to infinity. Watch how big the number. 2 to the power of 14. Because of the square here, is going to make the negative value when you square, that's a positive value, and a very small value, and that would make it go to plus infinity. You can make the table if you want to, but I can look at that because of the square. I know, well, this is going to be positive, so it will never be negative infinity. We're always going to be plus infinity. So is this one. If you pick a value larger than 3, like 3.00001, 2 divided by 3.00001 minus the 3. Notice that number is positive, and when you square it's still going to be positive, and that's 2 to the 10. That's almost infinity. So in this case, both of them is going to be to plus infinity, which means the limit as x approaches 3 now, for this one, it will be infinite. If I attempted to graph this one, if I attempted to graph that function, it will look something like this. We'll get to that later in the course, maybe in chapter 3 and 4. Let's say this is 2 over 9. It will be 2 over 9. And the graph will look like, there's the 3 here. That's a vertical asymptote. That's actually horizontal asymptote. That's coming up in chapter 4. That's vertical asymptote. So if I graph the function, it will look like this. That's what the graph will look like. So you can see as you approach, that's the 3 here, as you approach the 3 from the left side is going to infinity, from the right side is going to infinity. That will be what? Plus infinity. Now I can play with that. One minor change to that, instead of 2 here, if I put negative 3, what will happen? What will happen if I change that problem now, instead of being positive, to negative 2 over x minus 3? What's the limit now as x approaches the 3 from the left side? We know this number is positive here in the bottom because you're squaring it. But what about the number on the top?
So would it be negative?
Negative. So what's negative over positive? Negative. That will go to negative infinity. And if you try it from the right side, that will be a negative infinity. So you'll find the limit of this as x approaches the 3, since they are equal here, they're matching, I don't have to say which side, and that's a negative infinity. And again, the reason for negative, because the top is negative, the bottom is positive. Negative over positive will make it a negative. So it will never be positive infinity, it will have to be negative infinity. This is a positive over a positive, that's why it's a positive infinity. So you can tell if it's going to be a positive infinity or a negative infinity by just looking at the signs. Well, actually, the book does talk about vertical asymptote here, so let's talk about them. So this, I call this a vertical asymptote. Now, what is a vertical asymptote? Is actually, it's going to happen, by the way, where is it going to happen? What value makes the bottom 0? In this case, what makes the bottom 0? 3. That's why we have a vertical asymptote. As you approach that vertical asymptote, your function will explode. Will either go to plus infinity or to negative infinity. So when I look at a problem like this, and if I want to cheat and graph it quickly, let's say I want to graph f of x equals. Let me pick an example. 1 over 2 times x plus 1. Let's find the vertical asymptote. And to find where the vertical asymptote is located, you take the denominator and set it equal to 0. For the bottom to be 0, the 2 will never be 0. That means x will have to be what? -1. That is the only spot where if x is -1, this will be dividing by 0. So when I graph that, I always try to graph vertical asymptote with a red line to remind me, don't cross that line. Your function is n-defined at x equals to -1. So I draw that as a big vertical line. And I always draw an arrow pointing up or down, just to remind me, as you approach that value, as you approach that function, if you're rising, you will rise to infinity. If you're falling, you will fall to infinity. Let me just take a peek, see if they talk about horizontal asymptote while I'm at it. No, they don't say anything about horizontal asymptote yet. So we'll wait on that. So let's say I want to graph this. To graph this quickly to see what my limits will be, I can take 2 points and I should be good with that. I'll take 2 points less than the -1, 2 points to the right of the -1. So less than a -1, let's try a -2. And let's try a -3. When x is a -2, plug it in. What's -2 plus 1? -1 times 2, -2. That's a -1/2. When x is a -3, that's -2 times 2, that's -1/4. So I'm looking at it. Here's the -1, 2.5. -3, which is 1/4. It looks to me, the function looks like this. It's coming down. Well, if it's coming down, what's going to happen? Since you're approaching this line, that's your vertical asymptote, you will continue to go closer and closer. You never cross it. You approach it. So the graph will look like that from the left side. I knew it's coming down because the value is dipping down. Let's look at it from the right side. Let me pick the 0 and the 1. When x is 0, what do we have? 1/2. When x is 1, what do we have? 1/4. So it looks like this. Again, you're approaching this one. The vertical asymptote tells me you're going to go to plus or minus infinity. Well, if you're going upward, that means your function will continue to go upward. That's what the graph will look like. If I go to my calculator right now, I bet you will get something very close to that. 1 divided by, parentheses, 2 times, another parentheses, x plus 1, close parentheses. Graph. Look at that. With 2 points, 4 points, I managed to graph it. As you approach this line, you can't cross it. So it's asymptote. You approach them. So now you can look at that if you graphed it. If I ask you what's the limit of this function, as x approaches the -1 from the left side, where's the limit going to? The left side. Isn't that negative infinity? There's the -1 from the left side. From the right side, where is it going to? Positive infinity. Could you have more than one asymptote? Absolutely. So the limit from the left side is negative infinity. The limit from the right side is positive infinity. Let me give you one that could be like interesting one to graph. And quickly we'll look at it and see what the graph looks like, maybe with 5, 6 points, and that's it. Again, I'm going to graph that. I'm going to attempt to graph it. Let me rephrase it there and see if I'm right. While I got my ruler, where's the red color? I'm putting 2 lines here. Not 1, 2. I'm going to have 2 vertical asymptotes. Why 2? The vertical asymptote, here we go. This is asymptote 2. You take the bottom and you set it equal to 0. Can you factor that? X minus 1 times what? X plus 1. So we have x equals to 1, x equals what? Negative 1. We have 2 of them, the plus 1 and the minus 1. So this is x equals to 1. This is the minus 1. And to graph it, I just need to pick a few points. X versus y. I'm going to take color points in each piece, and we'll see if we can manage to graph it. Let me try to the left of minus 1, maybe the minus 2 and the minus 3. When it's minus 2, that's a 4. 4 plus 1 is 5. 5 over 4 minus 1, which is 3. So minus 2, it's a little bit more than 1. Almost 2, right there. The minus 3, that's 9. 9 plus 1 is what? 10. 9 minus 1, which is what? 8. Well, that's a little bit less. Somewhere here. So this piece, I'm done. I'm cheating a little bit there. I'm not going all the way to the bottom because I know my horizontal asymptote actually is 1. We didn't show you that. That's coming up later. But based on these numbers, it looks like the graph looks like this on these 2 values. Actually, if you want to know what that number, where you're starting from, pick a large value for x. Use 100. Notice when you have 100 and you square it, does it really matter if you add 1 or subtract 1 from it? No. It's going to be 100 squared over 100 squared, which is what? 1. Negative or positive, it doesn't matter. That's why you're going to start from 1 here, and you're going to end at 1. Now let's look in between minus 1 and 1. The bad news, I got to use fractions here. Let me start with the 0 first. I don't have to use a calculator for that. That's what? Would be a negative 1. Let me use a negative 0.5. Squared, that's 0.25. 0.25 plus 1 is 1.25 over 0.25 minus 1, negative 0.75. What is that number? That's probably more than negative 1. So it's down here. It's a negative number. It's more than 1. So I know my graph is looking like this on this part. Let's look on the right side. What about the 0.5? Same thing is going to be right. Same answer. Almost negative 1.67, I think. Same here. And now color points on this end after the 1. Let's take the 2 and the 3. When x is 2, that's 4 plus 1, 5. 5 over what, 3? When x is 3, is going to be the same as 10 over 8. So I can see it going like this. That's what the graph will look like. A Golden Gate Bridge. And now we can answer any question. You want the limit from the left side, the right side, for any one of these. If I walked in and I said, okay, now we know the picture, can you tell me what the limit as x approaches negative 1 from the left side of f of x? From the left side, what's the limit? Where is it going to? Positive infinity, right? What's the limit as x approaches negative 1 from the right side? From the right side is down here. Where is it going to? Negative infinity. What's the limit as x approaches the 1 from the left side? From the left side, where is it going to? Negative infinity. What's the limit as x approaches 1 from the plus side? Positive infinity. So we found all these limits, infinite limits for us. If I have the picture with me, it's not bad. If you don't have the picture, you have color option, either graph it and see what it looks like. And again, you're not going to have these graphing calculators handy for the test, so make sure you can pick points and do them with points. Worst case scenario, if you're not sure about the limit, use the table. Go to the table, plug in value. Oh, let me just pick a different one. I'm going to do them without the table. Try doing without the table. Let's say 1 plus. Here's how I see them. I'm saying 1 plus, right? Which means the number on the bottom here, when you do 1 plus, like 1.000000001. When you subtract 1 from it, is that positive or negative? If it's a plus, positive, right? So that number is going to be positive in the bottom. Very small number, but positive. Imagine if you divide it by 0.000000000. What does that mean? You're multiplying it like by 10,000 or 100,000. That's going to be a huge number. The question is, it positive infinity or negative infinity? Well, I know the number on the bottom is going to be positive. What about the number on the top now? If I use a number, it's going to approach infinity, this one, because you're approaching the 0 there. So the question is, a positive infinity or negative infinity? Let's take a positive number, like 1.00000. When you square it, minus 3 times 1.000, I forgot to put the 1 there. Well, think about that number. That's almost a 1. What happens when you square the 1? Still a 1. This is almost a 1. What's 3 times 1? 3. Over a positive number, what do you have? Positive or negative? That's a negative infinity. So without picking the points, I know I'm going to be going toward negative infinity.
How it will become positive in below, like 1 minus 1 will
1.0001 minus 1, right? It would be like 0.000001. That's a positive value close to 0. So you know it's going to, once that number is 0 on the bottom, you know it's plus infinity or minus infinity, unless it's removable. I can't remove it. I can't factor anything. So once you have 0 on the bottom, that's going to go to plus infinity or minus infinity. The question is, it positive or negative? Now, if I use negative value here, again, I'm not a 1, I'm less than 1. Like 0.999999. So if I use 0.9999, you subtract 1 from it, what will happen here? This is negative. If I use 0.9999 and I square that, minus 3 times 0.9999. Now you can see that's almost a 1 squared, that's a 1. That's a negative 3 over negative number. That's a negative over negative, which is what? Positive. That's going to go to plus infinity. How about the limit? That's how I cheat with these instead of making the table. Now that doesn't tell me positive or negative. So I got to do them both if it doesn't say positive or negative. So I got to look at it from the plus side. Let's pick a number close to 0 but positive. That would be 1 plus 1 over 0.000001 squared, right? That's a positive number. So you know the answer of this is going to be infinite. We'll take infinite, add 1 to it, what will happen? Still infinite. Now what about from the left side? This will be 1 over negative number. Again, when you take that negative number and you square it, what happens to it? It becomes a positive number. So that still goes to infinity, because positive over positive, that's infinity. We know it's going to go to infinity, just a matter of plus or minus. That's plus infinity. Add 1 to it, that's still plus infinity. So the answer to this is plus infinity, because they are matching. If I didn't have the square, it will not be. If I didn't have the square, this would be positive. That would be negative infinity, no limit as x approaches the 0. So a couple of options, either graph them. Again, direct substitution is the first one here. 1 over 0, that's infinite. The question is it positive infinity or negative infinity? And that's how you decide if it's positive infinity over negative infinity. It has to be non-removable, too. Maybe I can do one more. If I can find one more. Let's see. Find the limit. 5 minus 1 over x, I'm just making that up, as x approaches 0 from the negative side. I didn't say a plus side. I didn't say just 0. I was specific from the minus side. And if I do the plus side, I'll ask you for both, actually. Again, direct substitution says 1 over 0. And I can't clean that 0 from the bottom. So I know it's going to go to infinity or minus infinity. Which one is it? Is it positive infinity or negative infinity? Let's look at the 0 minus. You're not a 0. You're less than 0. Negative value. So this will be what? 5 minus 1 over negative 0.00001, for example. Let's look at that piece alone. When you divide by that, that's a huge negative number, right? Like that's minus what? 100,000. So if I make this number smaller even, it's going to be negative infinity. So the answer to this is negative infinity. But I have the minus in the front, I get the 5. So that becomes what? 5 plus infinity. Big deal. You get infinity, you add 5 to it. How much of a difference going to make? Not much. Where's it going? Positive infinity. From the right side, direct substitution, 5 minus, this is more than 0, so how about 0.00000001? And what's the answer to this? That's positive infinity, so 5 minus infinity, or negative infinity plus 5, which is what? Negative infinity. So what if you add 5 to negative infinity? So where's the limit going to? Negative infinity. What's the limit as x approaches 0 here? I didn't say which side. This will be what? D and E. It does not exist. But for this type of problem, they're only going to ask you this or that, because in this section, the topic is infinite limit. And they want to know if you know the answer is going to be plus infinity or minus infinity. And that's one quick way to see where the answer is going to. Is it plus or minus infinity?